Okay, hello everyone. This is the review for upcoming test. Let's start. Uh, Rewrite each equation as requested. Rewrite as an exponential form. So you need to change this log form into exponential form. So when you try to do this kind of problem, make sure that you know the equivalent um, formula. So log base b x equal y is equivalent to x equal b to the power y. You need to find out what is b, x, and y, and you can go from one format to another and vice versa. For the first problem a, you can see that b, the base is 3, x is 1 over 81, and y is negative 4. So if you change that to this form, so it will be 1 over 81 equal 3 to the power negative 4, and that's what we're going to write here. 3 to the power negative 4 equal 1 over 81. Okay, by using the very same equivalency form, we can find out b, y, and x. So because you can see that the base is 8, y is 2, and x is 64, so log base 8 of 64 is equal to 2. Okay, that's right. One more time, change it to the logarithmic form, e to the power 5x, since you know that the base is e and the exponent is 5 and x is x. So if you want to rewrite this as a logarithmic form, it would be you can write it as a, because log base e means it's ln. Okay, you can use ln, so you can use this one, ln, which is log base e of x equal 5. So as you can see that base is e, y is 5, and x is x itself. So log base e of x equal y. Let's go to the next. Here we would like to change that. We would like to change that to exponential form. As you can see that the log base e, so e to the power y equal 4, e to the power y equal 4. Okay, so log base 6 of 1 over 36 is equal to what? So there is a properties of log. You can use that one, or you can change this into the exponential form to find out this value. How do you do that? This is problem 3. So let's say for the first one, let's say you want to find the value of y, which is log base 6 of 1 over 36. I can change this to the exponential form, and then exponential form would be 6 to the power y equal 1 over 36, because 6 is the base and this goes on the exponent. Our goal is to find the value of y. So to find the value of y, we need to solve this equation. That means we can express on the right side, you can see that we can write it down 36 to the power negative 1, because if I take this 36 to the top, the exponent would be negative 1. And I know 36 can be written as 6 to the power 2. So 6 to the power 2 to the power negative 1, that gives you negative 2. And now because on the left side and on the right side there is the same base, that helps us to equate the exponent. So y should be equal to negative 2. So here this value, which is y, is negative 2. By using the very same idea, we can change this, and then we can find out the value of y is 3. Just exactly use the same way. y equal this expression 4 to the power y equals 64. 64 is actually 4 to the power 3, so actually y is equal to 3. So find the value of x. X is 1000 to the power 1/3. So simplify your answer as much as possible. So if you change this log form into the exponential form, you can write down by using the similar trick. I can write down this as an exponential form. X is equal to 1000 to the power 1/3, but we can write down this 1000 as a 10 to the power 3, and there is a power 1/3. Exponent to the exponent is just a multiplication, 3 times 1/3, so you can cancel this 3 and 3. This is basically 10 to the power 1, which is 10. So the answer here would be 10. So to solve this problem up to problem 4, as you can see that you have to know the properties of the log function. So here we have given the graph of log base 3x, and we want to plot the graph of this one. As you can see that log base 3x plus 2 means shift this graph 2 unit to the left, 2 unit to the left. So this 1 0 becomes negative 1 0, and then negative 3 means shift that graph 3 unit down. So 1 2 3. So this 1 0 point becomes negative 1 3, and we're done. So here we need to plot the graph of 3 log base 2x. So first of all, we should know the the point for the log base 2x. You can use the if you don't know how to calculate the log base 2x, you can use two different ways. The one way is plot the graph of 2 to the power x and switch the x and y coordinate, and that will give you the points for the log base 2x. Okay, so another way is just find the value of log base 2x by choosing x equal to 1 2 4, something like that, because log base 2, so choose something for x which is base 2, which can be expressed as a base 2. So as you can see here, this is problem 6. I'm going to use the second way, x log base 2x, and then that helps us to find out the 3 times log base 2x, which is just 3 times this value. So I'm going to start with let's say x equal 1, x equal 1, then this value would be 0, and this value would be 3. So the point you need to plot is 1 comma 3. So it says plot 2 points on the graph of the function and also draw the asymptote. So you have to draw the asymptote as well. So this is 1 point. Let's say at 2, log base 2 of 2 is 1 actually, and that will be, if you multiply this 1 by 3, that will be 3. So this one, 3 times 0 should be 0, sorry about that, and that will be 2 comma 3. So we know for the log base log function, the asymptote is the vertical asymptote, that is y equal to 0, sorry, x equal to 0 is the vertical asymptote, and here we're just multiplying that function by 3, so we are not shifting the graph of log base 2x to the left and to the right. So the vertical asymptote for this graph would also be x equal to 0. So what I'm talking is, for any function log base bx, so this is the graph, okay, 1 0, and this line x equal to 0 is called the vertical asymptote for this graph. Now instead of log base bx, we're trying to plot the graph for 3 times log base bx, so we are not shifting this graph to the left and to the right. So that means this vertical asymptote will remain same, x equal to 0. So for this function, the vertical asymptote would be the same, exactly x equal to 0. So I'm going to choose the vertical asymptote here at x equal to 0, and I need 2 points to plot. one is at 1 the function value is 0, we already found that. Another one is so at 1 the value is 0, and at 2 the value is 1. Okay, so now I just have to click this one, and that helped me to plot the graph of log function, because we're asked to just choose 2 points. And incorrect. What is the problem here? We are asked plot 2 points on the graph of the function and also draw the asymptote, then click on the graph of function button. Okay, so did I plot the wrong point? Oh, I'm sorry, instead of 2 3 I plotted 1 1 2. That's wrong. Okay, so I'm going to fix that. I plotted the wrong points. Instead of 2 3 I plotted 1 2. That's my mistake. Okay, so let's do that again. Let me just erase this thing and erase this point. So the only point is 2 comma 3. Got it? So now 1 comma 0 is already there. As you can see that 1 comma 0 1. This is 3 times 0 is 0. I'm sorry about that, it should be 0. And 2 comma 3, so that will be this one. Now let's try, and that's perfect. So when plotting this point, you have to make sure that you are plotting the right point. Okay, let's go to next problem. This is similar kind of problem, the log base 2x. After plotting that graph, you just have to shift that graph 2 units to the right. Okay, and give the domain and range using interval notation. So remember, if you go back here, these are the point. This is the base graph, and we're shifting that graph 2 units to the right. So that's problem 7. So if x log base 2x log base x minus 2. So if x is 1, the value of this is 0, and we're shifting that graph 2 units to the right. So the only thing will change on this graph would be the x coordinate. So when you shift this x coordinate 2 units to the right, it becomes 3. At 3 on this graph, the point, so I'm not going to find the points here. I'm not going to find the value of this function, but I'm going to find the points. This point, what happens to this point 1 0. So let me just erase this part here, and let me just find out the points on the graph and shift those points 2 units to the right. Shifting 2 units to the right means just change the x coordinate. So as you can see here, the point xy on this graph would be 1 0. Choose something else like 2, then this function gives you 1, so that's 2 1. So these points, when you try to go to the log base 2x minus 2, this point will be, you have to shift this point 2 units to the right, so that becomes 3 0, and this point becomes 4 1, and these points will be on this graph, the graph of this function. Make sense? So now when you shift the graph, you are also shifting the asymptotes. If you go back here, as we discuss here, the asymptote for this graph is x equal to 0, and you are shifting this graph 2 units to the right, so this x equal to 0 becomes x equal to 2. So first of all, this is x equal to 2, and then points are at 3, that will be 0, and then at just find out these points, the points we just got on the graph here. At 3, that's the value is 0. At 4, the value is 1. So at 3 the value is 0, at 4 the value is 1. This is 1. Okay, and this is the vertical asymptote. Oh yeah, we need to answer these questions as well. So by looking this graph, you can see that the domain start from this line x equal to 2 to the right. So the domain would be starting from starting from 2 go up to infinity. And range, you can see that anything from down to the up. So starting from negative infinity to positive infinity. That's correct. So find the domain. For finding the domain of this kind of function, this is the log function. There is a one trick for finding the domain of log function. Whenever you see log, which might be ln or log, whatever comes inside this parenthesis, make that thing greater than 0. So in this case, that's x squared minus 9. So domain of this function is where this function, domain of this f of x is when this expression is greater than 0. So you need to find out when this expression is greater than 0. You need to solve this inequality. Solving for this inequality needs a little bit work here. I can factor out x plus 3 times x minus 3, and I can find the zeros of these two factors, which is at negative 3 and at positive 3. So now to find out where this x squared minus 9 would be greater than 0, I need to check these three intervals, starting from negative infinity to negative 3, from negative 3 to positive 3, and from positive 3 to infinity. So these are the three intervals I need to check. So I'm going to pick three testing points from these three intervals. So let's pick the testing point, and let's pick three testing points from these three intervals. Let's say from here, let's pick negative 4, from here 0, from here 4. Now we need to find out the value of the x squared minus 9, this x squared minus 9, because this is x squared minus 9. We need to check where this expression is positive, negative, and we already know that this is the function f of x. So we need to check where this function is positive and where this function is negative by finding the value of the function at negative 4, at 0, and at positive 4. If you put negative 4 for x in the function, you will get positive value because it's x squared minus 9. So that means negative 4 is square minus 9, which is 16 minus 9, which is 7. That's positive. So the meaning is the function, this expression, so this is not f of x. Okay, let's say this is g of x, because we already use f of x for ln of this one. So let's say this is g of x. So this g of x, I have to change the name. G of x is positive on this interval, because this is positive at one point on this interval. So g of 0, if you try to find out that value, that is negative 9, and g of 4, which is 4 squared minus 9, which is 7, which is positive. So this x squared minus 9 would be positive here, negative here, and positive here. So if you go back here, that was our goal. If you go back here, we were trying to find out where this function g of x is positive, and we found that this function is positive on this interval and on this interval. So that means the domain of this log function is this one and this one. So if you go back here, the domain is from negative infinity to negative 3, union, there is a union, and from, let's go back and check, the function is this g of x is positive here and here. So that means from 3 to infinity, 3 to infinity. Okay, fill in the missing values to make the equation true. So here you have to use the property of log function. This is a plus, so you have to use the product property. log base 7, log base 7, 5 plus log base 7, 9. So that means it's a 5 times 9, which is 45. So here this is the quotient property. So log base 7, log base 2 of 7, 7 from here on the top, and here this is 27 can be written as 3 to the power 3, and because you want to write it down as a log base 9 3, so that 3, by using the power rule, you can bring that in front. So you have to use the properties of the log function: product property, quotient property, and power rule. Okay, if you want to expand this, you can use the same thing. This is the quotient, so log x squared minus log y, but you also have to use the power rule. So this is problem 10. So you can write this as log x squared minus log y. But if you read the problem, each logarithm should involve only one variable and should not have any exponent. So you don't want this exponent x squared, but by using the power rule, you can bring that in front. So that's how you can expand 2 log x, 2 log x minus log y. That's what we found. Let's go to next problem, problem 11. So we are going to use the same trick by using the the property of log function. We can just write it down log, whatever you have on the exponent, there is a radical sign. Radical sign means power half. So this will give you y to the power half, z to the power 5 to the power half. So eventually it will be g to the power 5 half. Okay, so and over x cube. So if I use the log property, because there is the quotient, so the log of y power half times z power 5 over 2 minus log x cube. Here you can see the product sign, so we can go one step further. By using the product property, it can be written as log y to the power half plus log z to the power 5 over 2 and minus log x cube. We can also use the exponent, the power rule. We can bring this exponent in front, so it will be half log y plus 5 over 2 log z minus 3 log x. So that's what we're asked to do here. If you read the instruction, it says expand as much as possible. So the first one is half log y, and then plus another one is 5 over 2 log 5 over 2 log z minus 3 log x. Okay. By using the very same idea, we can expand this one. Just use the quotient rule, log of this over log of this, and then use the product rule, and then use the again power rule, and you can expand this. I'm going to skip this. This is very similar problem. Okay, here we have to combine. So to combine, you have to see what is the minus and what is the plus. If there is a minus, and you have to also bring that number from the front to the exponent. So I'm going to do this problem. It's a problem 13. Before combining, before using any quotient rule or product rule, you have to use the power rule here. And don't forget that the base of each of these log function, they should be same, otherwise you cannot combine them. So this 4, I can write this as a log base 7 w power 4 minus this 1/3, I can write it down as a log base 7 as x to the power 1/3, and this 7 I can write it down as a log base 7 y to the power 7. So now there is a minus sign, so for in between these two you can write it down as a log base 7 w to the power 4 over x to the power 1/3, and there is a plus sign, so you have to use the product rule. So you have to use the product rule here, so that will be log base 7, this y to the power 7 goes on the top, that's the product rule, this times everything, so y to the power 7 times w to the power 4 over x to the power 1/3. So that is our final expression, log base 7. So there is a y to the power 7 w to the power 4 y to the power 7 w to the power 4, and on the bottom part it's x to the power 1/3 power 1/3. Okay, or maybe you don't have to write it down this. Okay, okay, that's good. Let's go to the next problem. Use the change of base formula to compute log base 7y. Round your answer to the nearest thousands. So you can use the change the base formula. So the change base formula is there is a formula, you can check that formula. This is problem 14, log base a of x. You can change this base to any other base, but normally we use log base 10 or ln, so I'm going to use ln here. So it can be written as ln x over ln of a. So by using this fact, if I use very same thing here, it will be actually ln of 6 over ln of 7. So this is I'm going to calculate here using the calculator. Ln of 6 over ln of 6, so parenthesis ln of 6, and then divide, but while dividing you have to come outside, and then ln of 7. So equal, it's a 0 point rounded to the nearest thousand, so after decimal 3 number 920, and then because you want to round it here there is a 7, so it should be 921, so 0.921. Okay, yeah, so that's fine, either you just write 0 point or point, that's okay. Let's go to number 15. Solve for x. So x means you can change this equation into exponential, because right now it's log, so I can use this form, log base bx equal y can be written as x equal b to the power y, and here at this place x, it might be something else, we don't care, it might be negative 3x plus 7. So just compare this one here, and by doing that we can say log base 4 negative 3x plus 7 equal 1 can be written as, solving this equation is equivalent to solving things from this parenthesis equal 4 to the power 1. So now solving this one is equivalent to solving this one. So to solve this one, just subtract 7 from both sides. Negative 3x equal negative 3 and if you just divide both sides by -3, so x would be 1. Remember, you are solving the logarithmic equation, so make sure that this is the part of the domain of the function. So you have to find the domain of the log function here you have given. And how do you do that? To find the domain, what you can do is you can just express this. To find the domain, this -3x plus 7 should be greater than 0. I had to find this domain early, but I'm doing it here. -3x plus 7, this one should be greater than 0. That will help us to find the domain. Okay, so -3x should be greater than -7, and if you divide both sides by 3, it will be x is less than 7 over 3, because if you are dividing by negative, this sign just flip. So the domain of the function we're using is anything less than 7 over 3, and this one is inside the domain. That's why we can accept this one as an answer, otherwise no. So remember, when you solve logarithmic equation, make sure you find the domain of the log function you are using here. If you have more than one log, then you have to find the intersection of all those domains. By using the very same trick, the way we did number 15, just bring the 4 on the on right side, and then change this into exponential form and solve this. This is exactly same as number 15, so I'm going to skip it. 17, very same. Let me just okay, so 17 is very same. So how do you do this? 17, 7 minus 3 ln of x equal 3. Make sure that the function you are using, the ln, the domain of this function is all real number. We know that the domain of this function is anything positive. So the domain is, because this x has to be greater than 0, so your answer should be from here. Now to solve this equation, first of all, bring everything on the right side except ln. So it gives me -3 times ln of x equal, if I subtract 7 from both sides, it gives me -4. Now I'm going to divide both sides by -3. So it gives me ln of x equal 4 over 3. Now what is the value of x? You can change this into the exponential form. So x is e to the power 4 over 3, because ln means it's a log base e. So to find out this value, you can just type it. It says do not round any intermediate computation and round your answer to the nearest 100. So type e to the power 4/3. So e to the power 4 divided by 3, and round it to the nearest 100. So 3.79. 3.79 is your answer. Okay, in this problem you have two log function, as I was explaining problem 15. So I'm going to do this problem 18. So I need some extra blank page. Okay, so this is problem 18. Problem 18, as you can see, 18, there is a log 5x minus 6. There is a 1 minus log 5x minus 2. So to solve this kind of problem, if you have the log, and then if there is a number only, bring all the logs on the one side. So I'm going to bring this log on the left side, so that means I have to add log base 5x minus 2. By doing that, I'm going to get log base 5x minus 6 plus log base 5x minus 2 equal 1. Before solving this equation, let's find out the domain for the functions we are using here. Domain. As you can see that this expression should be, this x minus 6 should be greater than 0, and also this x minus 2 should be greater than 0, meaning x should be greater than 6 and x should be greater than 2. N means intersection. So the intersection of x is greater than 6 and x is greater than 2. If I plot the graph here, there is a 2, there is a 6. Greater than 6 start from here, greater than 2 starts from here. So the intersection means wherever you see blue and red shading part. So the domain for this problem is, the blue and red both is this one. So the domain for this problem is 6 to infinity. That's the end. So if you find your answer something from here, then you can accept, otherwise no. So let's try to solve this one. How to solve it? To solve this kind of problem where you have some log function and there is a constant as well, combine this log function by using the the product property. You can write it down as log base 5 x minus 6 times x minus 2 equal 1. Now after that, you can change this log form to the exponential form. So I can write it down as x minus 6 times x minus 2 equal the base 5 to the power 1 by changing the log to the exponential. Now you need to solve this equation. If you had 0 here, then it would be very easy, x equal to 6 or x equal to 2. But here is a number, so you have to distribute this x minus 6 and this x minus 2. If I multiply this, it will give me x squared minus 8x plus 12, and on the right side it's 5. Now we need to solve this. So to solve this, just subtract 5 from both sides, and it will be x squared minus 8x plus 7 equals 0. So now you need to solve this one. You need to find the factor of 8 such that the product should be positive 7 and sum should be negative 8. That is negative 7 times negative 1. So I can split this as a 7x minus 1 times x, and that is going to give me the factor of this x minus 7 times x minus 1. So x equal to 7 and x equal to 1 are two solutions for this equation. But remember, the domain of this the function we're using is anything greater than 6. So if you go back here and if you see your choices, this one is not greater than 6, so that's why we cannot accept this one as a solution. So the only one solution we can accept is x equal to 7, because the solution should be greater than 6, and that is possible because we found the domain. So let's go here and type it. The solution is 7. Great. Okay, to solve this one, just make sure that you have the same base on both sides. To solve this kind of thing, you're going to use this b to the power x is equal to b to the power y. If you have the same base both sides, the exponent should be equal. So for this problem, on the left side there is a 32, on the right side there is a 16, but we can express 32 as a 2 to the power 4, no, 2 to the power 5, and we can express 16 as a 2 to the power 4, and there is a power negative x minus 2. Whenever you see power to the power, you can just multiply them. So on the left side there is a 5, and on the right side there is a 2, 4 times this, which is negative 4x, negative 8. Because they have the same base, you can write 5 equal negative 4x, negative 8. And our goal is to solve for x. So we can just add 8, which gives us 13 is equal to negative 4x. So to find out the x, just divide both sides by negative 4. So x would be negative 13 over 4, and that's the answer. Negative 13 over 4. Okay, it's a negative 13 over 4. Remember, you can always check the answer by plugging x equal to negative 13 over 4 and see, either it gives you the true statement or not. Okay. Okay, here in this problem, this is also exponential equation, but there is no way you can express 12 and 11 as a as a same base. So for this kind of problem, you have to take ln or log. So this is problem 20. There is a 12 x plus 9 equal 11 to the power 1. So I'm going to take ln both sides. By doing that, it means ln 12 to the power x plus 9 equal ln 11. So this exponent comes in front, x plus 9 times ln 12 equal ln 11. Just think about this, ln 12 and ln 11, they are just a number. Your goal is to solve for x. So if you have some number here, what would you do? You just distribute this number here. So it gives you x times ln of 12 plus 9 times, or you can just divide both sides by ln of 12 first. So let me do that. That would be more quick. So I'm going to divide both sides by ln of 12 and then subtract 9. So the goal is you just have to find out the x. So you are going to use the easiest and quick way. So I'm going to divide both sides by ln of 12, and by doing that, there is x plus 9 on the left side and there is this number. You can calculate this number by using your calculator and then subtract 9. So that will give you x equal this number, ln of 11 over ln of 12 minus 9. So now let's go to read the instruction we have given. Round your answer to the nearest 100. So we're going to type this one, ln of 11, and divide it by ln of 12, I guess. Yes, ln of 11 divided by ln of 12 minus 9. ln of 12 and minus 9. So let's do that. This is negative 8.035. If you round it to the 100, that would be negative 8.04. Negative 8.04. That's the rounding to the nearest 100. That's right. Okay, this is the word problem. As you can see, a principal of 3500 is invested at 3.75% interest, compounded annually. So you have to know the formula to do this kind of problem. Let me just add some extra page here. Okay, so this is compounded annually, so compounded n times a year. So this is problem 21. So you have to know the formula. The formula is a equal p times 1 plus r over n to the power n times t. That's the formula, where n stands for how many times a year, p stands for principal, r is rate, t is time in a year. In this problem, we have given principal 3500, we have given rate 0.0375. Whenever you see this percentage sign, just divide that number by 100. Compounded annually, that means the value of n is 1, and how many years will it take to accumulate 5,000. So you need to find out the time to make that principal 5,000. So that 5,000 is the amount after some time. So you need to find out the value of t. For this kind of problem, you can see that there are 1, 2, 3, 4, 5, 6 variable. Out of 6, if you know 5, then you can solve for the the last one. So in this case, we know everything except time. So let's plug this value back here. So it will be 5,000 equal, the principal is 3,500, 1 plus the rate is 0.0375 over 1, n times t, n is 1, so time n times t is just t. We don't know the time. Our goal is to find the value of t. So first of all, to find the value of t, divide both sides by 3,500. This is exponential equation now. So by doing that, on the left side we get 50 over 35 by cancelling these two zeros, and on the right side it's 1.0375 to the power t. And to find out the value of t, just take ln both sides. Ln 50 over 35, ln this number 1.0375 to the power t. By taking this ln, you can bring this t in front. So this is the number you have, ln 50 over 35. T is down now, ln 1.0375. Now to find the t, just divide both sides by this ln 1.0375. ln 1.0375. Now the t is this expression. Just type this expression on your calculator. So I'm going to do that here. ln 50 over 35, ln 50 over 35, bracket close, divide this by ln 1.0375, ln 1.0375, bracket close, equal, and that is 9.688. Write the smallest possible whole number. So you have to write down this as a whole number, smallest possible whole number. So smallest possible whole number, so that means if you round it to the nearest whole number, that is 10, right? Okay, in this case you have exactly the same problem, but instead of compounded annually, you have compounded monthly. So you are going to use the same formula, but the value of n would be 12, because compounded monthly means you are going to use the same formula, but the value of n would be 12. I'm going to skip this because this is exactly same problem we did here for finding the time. The only difference is the value of n, which is compounded monthly, so it would be 12. This is compounded continuously problem, so that means you have to use different formula, compounded continuous formula, which is a equal p times e to the power r times t. So Money Saver Bank offers a saving account that earns 2% interest compounded continuously. If Ashley deposits 3,500, how much will she have in the account after 5 years? So using this formula, the interest rate is 0.02, that's a 2%, and the principal is 3,500, that's 3,500, and time is given after 5 years, I guess. How much you will have in after 5 years? So the amount is, using this formula, it's 3,500 times e to the power 0.02 times 5. Just use the calculator you have given here. It's a 3,500 times e to the power 0.02 times 5. And if you use that, that will give you this number, read the instruction, do not round any intermediate computation and round your answer to the nearest cents. So after decimal there should be only two number. So it will be, you can see that there is a, if you want to round it to the nearest cent, that will be 10 cents. Okay, 3868 3868.10. Okay. Okay, if you read this question, this is also compounded continuous problem. How much money should they invest now at the interest rate 8.5% per year? In this case, you need to find the P instead of A. But you are going to use the same formula. The P is unknown, A is given, rate is given, time is given. After plugging all this value, divide both sides by this expression, A over this one. So because you have given A, you don't have given P. To find out the P, if you divide both sides by e to the power r times t, that will be P. So P is amount you want to have, the rate is given, time is given. In this case, if you read the problem, the interest rate is 8.5% and they want to have 9,000 bucks after how many years? 14 years. 14 years. Okay, so just plug the value of rate, time is 14, rate is 0.085, A is 9,000, and just solve this. I'm going to skip this calculation part for you. Okay, this is 9,000 over e to the power 0.085 times 40. And then that will be the answer. Just use the calculator. Just divide 9,000 by this number. Okay. Okay. The mass of a radioactive substance follows a continuous exponential decay model. So whenever you have continuously exponential decay or growth, you're going to use the same formula, but you have a to the power, A is equal to P times e to the power negative r times t. So you will have that rate, the negative exponent, negative value for the exponential decay. This A means future value, future mass. P means initial value, initial mass. Rate of decay is given. Time is should be given there. So in this problem, we have some radioactive substance which is going to decay, and at the beginning we have 5,195 kg of that substance, and which is going to decrease and with the rate of 12% per day, and find the mass of the sample after 4 days. So time in this case is in days. So at the beginning we have 5,195 kg. 5,195 kg. The rate is 0.12 and time is 4 days. So this rate is per day, that's why we can calculate this for the 4 days. So just plug the value of P, which is 5195, E negative 0.12 times 4, and just type this number on your calculator. So that would be 5195 times e to the power negative 0.12 times 4. So after 4 days, we will have 3,214 point, if you want to round it to the nearest 10, 3,214.6 kilogram, nearest tens. So 3,214.6, because after 5 there is a 7, so you have to round it to the next number, which is 6. You see that the at the beginning we have 5195 kg, and it's going to decrease because it's a we are using the decay model. Okay, so let's go to the next problem, exponential growth model. So very similar kind of problem, but for the growth model you don't have negative sign. So for problem 26 you are going to use very same formula, a equal p times e to the power r times t, where p is based on what you have given in this problem. P is the initial, a is the future, r is the rate, t is the time. In this case it's about population of bacteria, so p is initial population, a is the final population or population after time t. So in this case we have given the bacteria is going to grow at a rate of 4.4% per hour, and now we need to find out how many hours does it take for the size of the sample to be doubled. So we don't know what is the value of p and what is the value of a, but we know that we want to find out the time when a is 2 times p. Double size will be double, means a is equal to 2 times the initial population. So in this problem what you can do is, instead of a you can write 2 times p. P is already there, the rate is given, we have 4.4%, so that means 0.044. time is unknown. Without knowing your initial population you can just write down a as a 2 times p. Now if you divide both sides by p, it will be 2 equal e to the power 0.044 t. So to find out the t, just take ln both sides. If you take ln, the right side would be this, ln and e will be cancelled out, so right side you are going to get 0.044 t. And now to find out the value of time, just divide both sides by 0.044, and that will give you the time. So to find out the time, just type this number on your calculator, that is ln2 divided by not inside, outside, divided by 0.044. So that many hours it needs, 15.75. You want to round it to the nearest 100, so that would be 15.75. that many hours, 15.75 hours. That's good. Let's go to the next problem, problem 27. Three systems of linear equation are given. These three equations. For each system, choose the best description of its solution. As you can see that there is a one solution. So the system has exactly one solution, and the solution you can read from here. This is -2 and -3, and you can write down that solution here, -2 and -3. In this case L1 and L2 they are same, so there should be infinitely many solutions, because at each point they are just intersecting, so infinitely many solutions. For here you can see that L1 and L2 they are never going to intersect, so the system has no solution. Okay, so let's check it. Yes, let's go to next problem, problem 28. So use the substitution to solve the system. So you have given system of equation, you want to use the substitution method. So let me just add some extra page here. Substitution method. Okay, so this is problem 28, and for the substitution, first of all you need to find out the one variable, and it is already given. X is equal to 3y minus 15 is already given, and you are going to substitute this value of x in the second equation, which is 5x minus 2y equal -23. So I'm going to substitute x is equal to this value here. So I'm going to replace this x by this 3y minus 15. So just see here, 5 times x minus 2y equal negative 23. And as you can see that x is 3y minus 15. Now we need to solve this for y. For that we can just distribute this 5, that will be 15y minus 5 times 15 is 75 minus 2y equal negative 23. Combine this 15y and negative 2y, that will be 13y negative 75. And now just solve for y. We can just add 75 both sides. It will be cancelled out. 13y equal positive 75 negative 23, that will be 52. Just divide both sides by 13, so that is 4. So the value of y is 4. Now to find the value of x, you can go back and use the equation 1. Just plug x equal to 4 here, that will be y equal to 4 here, and then that will give you the value of x. X is 3 times y minus 15. So 3 times 4 minus 15, which is 12 minus 15, is equal to negative 3. So x equal to negative 3 and y equal to positive 4. That's the solution of this system. Negative 3 and positive 4. After finding the solution, remember, always check your answer. So negative 3 and positive 4. So that's the answer. Let's go back here. Negative 15, positive 4, negative 8, negative 23. So I checked it in my mind, but you can do it, you can just plug x equal to 3 and y equal to 4 in both of the equation, and this would give you the same value. And I checked it, and that's right. Okay. Okay, solve the following system of equation. You can use any method for solving this one. I'm going to use the addition, because if you add this two equation, this 2x and negative 2x, it will be cancelled out. So it will be easier for me. This is 29. 2x minus 3y equal positive 8. Negative 2x positive 6y equal negative 20. And if I add these two, I'm going to use the addition method. So if I add these two equations, this will be cancelled out, and here it will be 3y equal negative 12. And if I just divide both sides by 3, y equal negative 4. That's my solution for y. And for finding the value of x, I will pick one of the equation, like I will pick equation 2, which is negative 2x, or maybe equation 1. I don't want negative 4x on the left side, so I will pick equation 1. So 2 times x minus 3 times y is equal to 8. So I'm going to plug y equal to negative 4, and I'm going to find out the value of x, which is 12 equal 8. And if you just subtract 12, that will be 2x equal negative 4, and just divide by 2, that will be x equal negative 2. So the solution for this system of equation, remember, always after finding the solution, check it. It's negative 2. For me, it doesn't matter, because if I get it wrong, then I will come back and I will check it. But for you, you don't get that second chance. That's why check it. That's right. Okay, this is another system of equation. I will skip this. You can solve it by using addition method or substitution method. Okay, so you can do the same thing here. Try to solve it. If you find the solution, then just write down the solution. If you don't find the solution, just say the system has no solution. Sometime you are going to get the same equation. In that case, the system has infinitely many solutions. So just play with these two equations. As you can see that if you use addition method by making this negative, it will give you x equal, it's easy. So just check find the solution. If you don't find it, just say I don't find the solution. Yeah, one more time, very similar to 32, but I'm not going to skip it. I'm going to do this one. This is exactly same as previous problem, and I skipped the previous problem. That's the reason I'm going to do this one. I'm going to add one blank page here. Okay, so here you can see that for the first one, negative x positive 3y equal 9, positive x, and that's problem, this is problem number 32. This is 32. Positive x negative 3y equal negative 9. So if I add these two equations, okay, as you can see that here, the only difference between equation 1 and equation 2 is if I just multiply by negative 1 to this equation 2, then what happens here? You see, for doing the problem, if I just they look very similar, so I'm going to multiply both sides by negative 1 to this equation. That will give me negative x positive 3y equal positive 9. But this is exactly same as equation 1. So that means I'm trying to deal with the same equation. So that means whenever we try to deal with the same equation, we will have infinite solution. The system has many solutions, infinitely many solutions. And for finding the value of y, just solve for y by using one of the equation. Like let's say use from here, just try to get y. So how do you get y? Just bring this x to the right side by adding x. So that will be 3y equal 9 plus x. Now you want to find out the y, so just divide both sides by 3. That will be y equal, if you divide 9 by 3, that will be 3 plus x over 3. So that is your solution, and that will be infinite many solutions. So 3 plus x over 3. And you can do the same thing here on the second problem. You can see that if you just multiply by okay, it looks a little bit different, so let's do this one. Second problem, part B. Negative x positive 3y equal positive 3. Positive x negative 3y equal again positive 3. If you try to add these two equations, you are going to see something unusual. This gives you 0 because negative x and positive x is gone. Positive 3 and negative 3y is gone. But on the right side, you will get 6. If you add, it's giving you some wrong statement, 0 equals 6, which is not possible. That means we cannot find the solution of this system. So that means the system has no solution. When you try to simplify to solve the system, if you get something unusual like this, which is not possible, that means there is no solution. Okay. This is application problem for this solving system of equation. If you read this problem, it says a fruit company delivers its fruit in two type of boxes, large and small. A delivery of 3 large boxes and 5 small boxes has a total weight of 116 kg. A delivery of 9 large boxes and 7 small boxes has a total weight of 238 kg. How much does each type of box weigh? So you need to find out the weight of each type of boxes. So because you are trying to find out the two different things, we are going to use two different variables here, x and y. So this is problem 33. Let's say x is the weight of the small box, large box. So this is weight of large box. Remember, for this kind of problem, this application problem, word problem, for system of equation, whenever you have to find the two different thing, introduce two variable x and y. The variable x is for the first one and variable y for the second one. In this case, this is weight of large box and small box. Now try to use the given information here and try to create the equation. As you can see here, a delivery of 3 large boxes, so that means the weight of 3 box plus weight of 5 box is 116 kilogram. So from here you can write 3 times x plus 5 times y equal 116 kg, because delivery of 3 large box, which means 3 times the weight of this large box plus 5 times the weight of this small box, altogether it will be 116 kg. And for the second one, delivery of 9 large boxes, that means 9 times x plus 7 times y is 238 kilogram. You need to solve this system of equation. To solve the system of equation, you can see that you can use addition method or you can use the substitution method. So I'm going to use the addition method. For the addition method, we need opposite coefficient. And here there is a 3x and there is a 9x. So what I'm going to do is I'm going to multiply this first equation by -3 to make this -9. So look at here, I can do that. I can multiply both sides of any equation by the same number. So I'm going to multiply this first equation by -3. So I'm going to multiply this first equation both sides by -3, and that will change my equation to -9x, -15y, -116 times 3 is 348. This is the same as equation 1. Now I can add this to equation. So if I add this equation 1, this is equation 1. This is just different form of equation 1. And 2, this 9x and -9x, they will be cancelled out. From here I will get -8y. From here I'm going to get -110, right? So if I just divide both sides by -8, it will be 8 equal 1. So if you divide 110 by 8, so what do you get? 110 divided by 8 is 13.75 kg. That's the weight of a small box. So to find the value of the large box, you can pick one of these equations and plug y equal to 13.75 and solve for x. I'm going to choose equation 2. So equation 2 is 9x plus 7 times y equal, you can choose any of them, 238. So we can plug the value of y, 9x plus 7 times, this is 13 times 75 equal 238. Just multiply this number, which is 13.75 times 7 is 96.25. It's a 96.25 equal 238. Just subtract this 96.25 from both sides. Use your calculator. 9x equal from 238, it gives me 141.75, and if I divide both sides by 9, it will be x equal 15.75. So the weight of the large box is 15.75 and weight of the small box is 13.75. Remember, you can always check this your answer by plugging this value of x and y back in this system of equation. I'm not going to do that myself. I'm going to check it directly here because I can do that, but not you, because you don't get another chance. Okay, so x equal 15.75, that's the weight of large box, and y equal 13.75. Okay, I was right. Problem 34. The Royal Fruit Company produces two types of fruit drink. The first type is 20% pure fruit juice, and then second type is 45% pure fruit juice. The company is attempting to produce a fruit drink that contains 35% pure fruit juice. How many pints of each of the two existing type of drink must be used to make 150 pints of a mixture that is 35% pure fruit juice? So first of all, we need to understand the question here very carefully. So this is the last problem, 34, and there are two different kind of drink we have. First fruit drink and second fruit drink. How many pints of both drink we need to use? So there are two variables we're going to introduce. One for x, which is, let's say, the first fruit drink. So that's the amount of the first fruit drink, and this is the amount for the second fruit drink. The unit of the these amounts are pints. So x pints, y pints. Now go back to this problem and look at here. The first type is 20% pure fruit juice. So this first type, this x is, there are two different type. We're using x from the first type. This is first type, and there is another type, and from here we're using y pints. So this is first type, this is second type, and we have given that this is first one is 20% of the pure drink. 20% of the pure drink. So 20% of the pure drink, and this one is 45% of the pure drink. We want to use this two fruit drink, first and second. We want to mix them, and we want to create the mixture. We want to mix them. We want to put them in the one single place, and we want to make the mixture, and that mixture should be 35% pure fruit juice. And then we want to make that 150 pints. So we want to mix them, these two, and make 150 units pints, such that this mixture should be 35% of 35% pure. So remember, the first one is 20% pure, the second one is 45% pure, and when we mix them, it should be 150, but that should be 35% pure. One thing keep in mind, we want to use x pints of the first ring and y pints of the second ring, and after mixing, that x plus y becomes 150 pints. So that's the first equation we have given. And now for the second one, we're going to use their mixture percentage. 20% of x plus 45% of y is 35% of 150. So 20% of x, which is 0.2x plus 0.35 of y is 0.45 of y is equal to 0.35 of 150. So these are the two equations you need to solve. I don't like this decimal number, so I'm going to multiply this equation 2 both sides by 100. By doing that, I'm going to get 20x plus 45y equal 35 times 150. So that is, you can just multiply 35 and 150. I'm using my calculator here. 150 times 35, 150 times 35, that is 5250. Now our goal is to solve this equation 1 and 2. If you look at the equation 1, I can just write it down as y equal 150 minus x, and I can substitute this value of y back here. So 20x plus 45, 150 minus x equal 5250. So now we need to just solve this equation here. Just distribute that 45 times 150, 45 times 150 is 6750 minus 45x equal 5250. Just combine these two terms and subtract 6550. It will give you on the left side it's negative 25x. On the right side it's subtract 5250 from 6750, and that will be 1500. negative 1500, divide both sides by negative 25, and that gives me the value of x, and that's 60 pence. The value of x is 60 pence. And to find the value of y, you can just go back here and then subtract x from 150, and that is y equal 150 minus 60, which is 90. So to make 150 pints of 35% pure juice, we have to add, as you can see here, 60 pints of first drink and 90 pints of the second drink. 60 pints of the first drink and 90 pints of the second drink. So 60 and then 90. Okay, so that's all the best.